right, here we go. 5 practice problems, and these range from the easy to the not so easy. So let's get started. Letter A asks us to find 3 rays and 3 angles in the diagram. I'm going to note that the easy rays for me to find are SR, ST, and SP because all of them start with S. I could do PS, PR. Technically, PT could be a ray even though it's not shown in the diagram as being a ray. I might stay away from that one because I'd have to argue it. But here we go, and I'm just going to go ahead and put a ray notation over the top of these things so that we know what we're dealing with here. I probably should have made my ray notation just a little bit bigger, but what can you do? And then 3 angles, so I'm going to copy the angle here. Okay, so actually let me do that. So we need to find 3 angles in here, and there we don't have quite so many options. Now, can I name any of these angles by just naming the vertex? The problem is that the only vertex is S, and it refers to 3 separate angles. All 3 angles that I'm going to name have S as a vertex. So therefore, I can't just say angle S, because S refers to multiple things. But I could say angle RST, could have also said TSR, angle TSP or PST, and angle PSR, that straight angle all the way across the bottom there. All right, there we go. That's letter A. Letter B, classify ABC and use a protractor to find the measure of it. Okay, so here's something that we're going to have to know how to do. In the book, every once in a while, there will be an angle that we have to find a measure of using a protractor. And one thing we're going to find about these angles is that they're usually way too small to actually find a measure of using a protractor. So I'm just going to see if I could paste this the same size here. Let's see if this works. Yeah. I'm just going to drag this off to the side. Okay? And then I'm going to bring, let's see, I want my protractor to be, this is going to be a tricky one. Here's what I'm going to have to do. This is what I'd have to do anyway. I have to extend the lengths of the sides on here. So one thing you can do in geometry whenever you have a line segment or a ray, if you want to make it longer, especially a ray, because notice that this ray starts at B and then it continues for an infinite distance in this direction. So one thing you do is get a straight edge, copy the original angle on a sheet of paper, get a straight edge, and just extend the length of the ray. So I'm going to do that for that one, and we're going to do that for this bottom one as well. That's not what I wanted to do. Hold on. Dude. And what I'm going to do, I think, is just do a line here. And we'll bring it in from the side, straight over. And then I'm just going to move it up, 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 up. And then we have our line and our ray. Perfect. Okay, now I've extended this angle. I'm going to get rid of the original. And the way that this would look for you is when you do this, you would copy the original angle out of the book by putting a piece of paper over it, tracing it. Then take a straight edge like a ruler and make AB longer and make BC longer to make this longer angle. And now I should be able to take my protractor. Let's see what happened to my protractor here. I'm just going to copy and paste the protractor. All right. I'm going to move my protractor. Let's see. Send it back. And now I should be able to use this protractor to measure my angle. I have to get that little crosshairs at the bottom directly on the vertex of the angle. And let's see. So because I'm treating 0, this side is going to be treated as 0. I'm using the top scale, which treats this as 0. Goes all the way around, and it looks like this angle has a measure of 123 degrees. I would estimate that as about 123 degrees as the angle measure. Now, I would say also that if you were doing this, depending on how well it was copied and how well your straight edge worked, it's probably going to be anywhere between 120 and 130. I mean, it could be anywhere from 120 to 130, probably really close to 125. Okay, But that's how we would do that one. The next, so those are the two complicated ones. The next ones get a little easier. So determine the measure of angle AEB if the measure of angle AED is 120. Okay, so angle AED is 120. I know that that full angle equals the sum of the little angles. One of the little angles is DEC at 33. Another little angle is CEB at 22. And then I've got this third angle measure, AEB. And I'm just going to call that X for right now. I don't know the length of that one, but that's pretty easy to find. So I could simplify this. 120 equals 55 plus X, combining like terms. Then I'm going to subtract 55 from both sides. Let's see, 120 minus 55 is 65. So 65 equals X, or the angle measure, the other way to say this, and let me just grab my angle measure to get this right. So the correct way to put this would be the measure of angle AED equals 65 degrees. And then I would just superscript that so it looks like a degree symbol. Letter D is only hard if you don't have good attention to detail. So you need to pay attention to the details that you know about the figure in letter D. And what I'm going to do is, just as I go along, I'm going to make sure that I put in the angle measures that are on this figure right away as we talk about them. That's going to help me keep track of what we know. So the only reason that D is hard is because, first of all, there's something that you have to notice in the figure, and if you don't notice it, it's complicated. But also, you have to keep track of a lot of angle measures. All right, so the first thing we know is that the measure of WXY is 32 degrees. I'm going to put in angle WXY the measure 32 degrees. XY bisects WXZ. Here's XY, here's WXZ, and what that means, if it's bisected by the ray XY, I can put this 32 degrees over here too. These angles have to be the same because they're on either side of the angle bisector. Okay? Now, I also know that the measure of UXV is 35 degrees, and here's where things get complicated to notice. Just what do you notice? So 35 degrees. Do I know the measure of ZXU? Why, I sure do, because there's an arc mark there. And that arc mark indicates that it's the same as UXV. So what I'm going to do is I'm going to copy this 35 degrees up to here as well. And then the question is, find the measure of YXU. Well, let's see here. I'm just going to go ahead and write this the correct way. The measure of angle YXU equals, in this case, it's going to be 35 plus 32, because it's both of these small angles. So 35 degrees plus 32 degrees. And this one's pretty easy to figure out even without going through the extra step here, but I'm just going to be thorough. So 35 plus 32 is simply 67 degrees. So my total angle here is, and let me just put it in here for, again, to be thorough, 67 degrees. All right, the last one. A survey shows that 10% of students in a class did not eat lunch. What would be the degree measure of an angle indicating these students on a circle graph? Okay, so this question's a little hard if you don't know what we're talking about with a circle graph. You might want to go back and look at example 5 in the textbook just to see what a circle graph looks like. But here's what I know about a circle. A circle has 360 degrees. So if a circle is 360 degrees and I'm showing a wedge that's 10% of that, I'm going to do 360 times 10%, or times 0.10, right? 360 times 0.1 is just 36, and it's going to be 36 degrees as an answer. All right, those are the lesson practice problems. You're now ready to do numbers 1 through 30 for this assignment.